We're going to deal with the issue that happens often in the real world when there's more than one conditional stimulus. So far we've looked at examples where there's only been one CS paired with one US. In reality, there's more than one stimulus available in the environment. And so as a quick example, imagine there are two siblings, Roberta and Mac. They're both trying to get their mother's attention at the same time. So Mark's voice just happens to be really loud and kind of attention-getting, whereas Roberta's voice is very soft. In this kind of case, the mother might end up focusing more and being more aware of Mark's voice than Roberta's voice. And if that was the case, we would say then that would be an example of overshadowing. So both voices are present, and she's probably associating them with, okay, if I hear the kids, yelling and stuff, they're probably playing, or they want, to borrow some money or whatever it might be. But she focuses much more on Mark's voice just because that's the one that's louder and more attention-getting than Roberta's voice. They're both there present in the environment, however, but one is just more intense, more loud, and more attention-getting. Would both be associated with the US equally? So no. So this is kind of an important point that we're going to start looking into situations where the association that develops, the learning that happens, isn't equal across the different conditional stimuli that are present. So in overshadowing, we already see one example where one stimulus is just more intense, more loud, more attention-getting, and therefore overshadows another conditional stimulus. So that's the first case. Now we're going to look at another case. What if at first there's one conditional stimulus, but then another one is added? Will it become associated with the unconditional stimulus as well? And this gets us to something called blocking. And as the name implies, in this situation, we kind of have this recipe for one stimulus to prevent an association to develop with another one. It's going to block the second one. We're going to look at an example of blocking with phone rings, but let me show you another example really quick from something a little more familiar. So here we're going to see what happens in this household when the can opener turns on and the cats hear it. So the cats come running, right? That is a really classic example that many of you who have pets in the home have probably noticed, and cats are really famous for this. When they hear that can opener go on, they come running from wherever they might be. They develop such a strong association between the sound of the can opener and food. So the sound of the can opener, that's a conditional stimulus, a CS. What if now the owner of the cats decides that she wants to try and train the cats to come, to kind of condition them by calling their name? So she's hoping that just like they come running when they hear the can opener, that they will come running when they hear their names being called. This would be a recipe for blocking. And what would happen is she might turn on the can opener and start calling them, Seymour, Frederick, come over here. And she would hope that they would learn to also associate their names being called with food. Unfortunately, that's not going to work, or most likely not going to work, because again, this is blocking. And so we're going to see that learning about one relationship first can prevent you from learning a second one later. The cats have already learned to come running when they hear the can opener. They've already learned to associate the can opener with food. That means that you cannot easily add a second stimulus like their names. And the reason is, we're going to see, is that they're not going to pay attention to it. They can already predict what's going to happen based on just hearing the can opener. So their names, from their perspective, aren't really meaningful. This type of conditioning has two phases, a phase 1 and a phase 2, and that's really key. Phase 1 is the initial learning, or when the cats first learn to associate the can opener with food, right? We're going to do an example with the phone. And so phone ringing is going to be the conditional stimulus. So imagine you work at a particular store and there's obviously a phone there and you have to answer it when it calls. And so the phone rings and you answer it. It might be a customer calling. It might be someone from another store calling to see if you have some inventory or to ask a question or something along that. So it might be, a customer or a fellow employee at another store. Now what happens in phase 2 is that a new stimulus. So A is the phone ringing. B, we're going to see, is a different stimulus. And that different stimulus is the flashing light. And by the way, I know we're seeing this plus here. The plus represents that this is an important event. This has some unconditional stimulus present. So that's what the plus is telling us. And so the phone rings and the important event is that you need to communicate either with a customer or with a fellow employee, right? In phase 2, everything is the same. The only thing that's been added is that now a flashing light is added to the phone. So the phone rings as well as there being a light that flashes by the phone. And what we would see is that if you add the flashing light after, at a second stage, we're going to end up with blocking. That's what we're seeing here on the right. So let's start off by focusing here on the left real quick and looking at what would happen in a situation where you would want conditioning to happen. So in phase 1, nothing happens. In other words, there's no history of just hearing the phone ring. From the very beginning, it's the phone ringing, which remembers A, accompanied by the light flashing, which is B. Both these guys are present from the very beginning whenever someone calls. And if you do that, as long as there's no overshadowing, you could potentially get equal conditioning to A and B. So you can see that the strength of the conditional response to answer the phone is pretty equal, both if you just hear the ring and if you just see the lights flash, because there's no prior history and so there's no blocking here. In the blocking group, we can see that because there's initially history where the phone rings by itself and only later do they add the light flashing. Now, if you compare the amount of conditioning that you get when you hear the phone ring, the employees, you're going to answer the phone, definitely when you hear the ring. But the light is not going to be very effective. So here, our light stimulus is here in B. And if the employee does not hear the phone ring but only sees the light flash, they won't know that that means that there's someone calling the store. Why? They've only paid attention to the ring, not the light. Why? Because they had several months, maybe even years, using just the ringing of the phone to figure out that someone was calling the store. And so here in this example, we have blocking. The addition of the flashing light after the phone has been ringing to indicate that someone's calling for several months or years is just not effective and doesn't lead to any attention being paid to it and doesn't lead to any conditioning to it. So why did the second stimulus B, get blocked? Well, basically B does not give you any new information, so it gets ignored. Now, how would you get unblocking? To get unblocking, you have to make it so that the blocked stimulus is no longer ignored. In other words, you have to make it important. You have to make it provide some kind of new information. When the phone rings by itself without the light, you know it's a customer calling. But if the phone rings at the same time that the light is flashing, you know it's not a customer, it's a fellow employee from another store. And because of that, you might be more motivated to answer that call because if you help them, they help you, and you might have some more incentive to pick up the phone in that case, as an example. And so we have to make it for the flashing light to provide some new information. It has to do something different. And so I'm representing that with the 2 pluses over here as opposed to just the 1 in phase 1. That is what's unique, and that is what gets a new stimulus to be able to be unblocked or to be able to essentially develop an association. That new stimulus that you've added has to provide something new. So in the case of the cat owner who wants to call her cats when it's food time, what she might want to do is distinguish between perhaps different kinds of food. If the cats have a favorite kind of food that maybe they only get like once or twice a week, she should save the calling of the cat's names for those events, and they will probably then start paying attention and distinguish between just the sound of the can opener, which is providing them just their regular food, versus the sound of the can opener with their names being called, and now they know they're going to get the really special food. And so in the future, if she calls their name, they will probably come because they have learned to pay attention to it, because it does give them some new information. It tells them, oh my gosh, now they're going to get that really special food. And so if you unblock by allowing the new stimulus to provide some kind of new information, we can see that it strengthens the association, produces a strong reaction in contrast to blocking. So blocking and unblocking is really useful, not just because it's practical, but also because it can teach us a few things about what facilitates learning, what allows these associations to happen. So one thing that we've learned as a result of understanding blocking a little bit is that we can see that there has to be like an element of surprise for learning to happen. And what that means is learning is really about trying to figure out what's going on in your environment, trying to figure out what might happen next time. And so if you're surprised by something, you're going to look around, you go, oh my gosh, something happened that I did not expect. How can I not be surprised by this next time? How can I anticipate this better? And so that element of surprise is what makes you sort of focus and pay attention and hopefully learn something so you can predict what might happen next time much better. The other thing it tells us is that learning is not determined by what's called contiguity, just a fancy way of saying pairing. This is what Pavlov thought originally that allowed learning to happen. He just thought if you just pair two stimuli, there would be an association. You pair a bell with food, bang, there's going to be learning. Now we know that's not true. We know that it's not just pairing. You can pair the flashing light with a phone call day in, day out for months and years, but there won't be any learning to it because the phone ring is the only thing that you're really paying attention to, because it's gotten you this far, right? Why even pay attention to any new stimulus? Why would the cat pay attention to their names being called if all they really have to focus on is the familiar can opener? So just pairing the names with food is not enough. The calling of the names has to provide new information. Now, to incorporate this notion of surprise, two psychologists working independently ended up developing really a very similar model. So they collaborated eventually, and the model got named after the two of them, and it's the Rescorla-Wagner model. And we're not going to go into all the details of the model, but it does give us some important guidelines for the situations that influence how learning is going to happen. You know, kind of help us explain when will an association develop versus when it won't. And so the three situations that they highlight are right here. So the first one is the US was not expected. In other words, there's an element of surprise, right? So if there's an element of surprise because something important happened, this unconditional stimulus came on and occurred and you didn't expect it, that's going to make you feel a little surprised. It's going to make you pay attention to try and predict that unconditional stimulus in the future, and that situation is going to strengthen the association between the conditional stimulus and the unconditional stimulus. So when a cat hears its name called, they are surprised by getting, tuna instead of their regular cat food. They're going to definitely start paying attention, and there's going to strengthen the association then between hearing their name called and expecting tuna instead of cat food. The other thing that can happen is that the unconditional stimulus was completely expected. Oh, boring, right? So no surprise here, and therefore no new learning happens and no change. The third situation that can happen is that the unconditional stimulus was expected, but it didn't happen. In other words, the cats heard the can opener, but they didn't get any food. If that happens over and over and over again, it will weaken the association between the CS and the US, or in the case of the cats, the sound of the can opener and their cat food. So we can strengthen the association in number 1, we can leave it alone in number 2, or we can weaken it in number 3. And so I want you to take a moment and try and apply the Rescorla-Wagner model to these 3 examples involving a student. And this is going back to part 1, where we had the example of the teacher yelled at the student, making the student feel really uncomfortable in class and leading to some anxiety in the future when the student's in the class in the presence of that teacher, right? In this first one, a student expects the teacher to yell at him, but the teacher doesn't. In the second one, the student expects the teacher to yell at him, and he does. And in the third one, the student is unexpectedly yelled at by the teacher. So match these 3 with the 3 situations in the Rescorla-Wagner model.